Great. Well, morning, everybody. My name is Liz Barrington. I'm the marketing manager at Sensor City. Welcome to our Sensor City's Arrow Comes Home webinar series in partnership with Arrow Electronics. Really pleased that everyone was able to join us this morning for our first of the online webinars. We do usually run a number of events in our Innovation Hub itself, but as remote working and remote learning is now becoming the new norm, we thought we'd bring the events right to your home. So today's session is focused on wearables and medtech, and we have run a number of events with this kind of focus before, most notably our Smart Health North event earlier this year, which focused on Liverpool City region and the solutions that were coming out of the startups and SMEs within our region. Given the current pandemic, this area of technology is becoming ever more important. So given the current COVID pandemic, I think it's definitely a good area to start on with these tech seminars. Today, we will be joined by three guest speakers from our partner Arrow's network. And they are tech vendors with specialisms in electronics, but each will be giving their own take on the applications for the healthcare sector. And they'll be giving a 30-minute presentation each with the opportunity for questions and answers following each presentation. If I could ask if you could make sure all of your microphones are muted throughout the presentations, but if you do have a question to ask, and we do encourage the questions, then please do add them into the chat function, and each speaker will address all of the questions posted after their main presentation has. Final thing to note is that we are recording today's session, just so in case anyone's unable to make this live session, they can catch up with it later, or if you particularly enjoyed it, you are more than welcome to watch it again at leisure. So there's three speakers we have today. First up will be Philip Hart from Microchip, who will be covering overall trends with medtech and IoT devices. Then he will hand over to Scott Cooper from Silicon Labs. His focus will be more around wearables and the electronics and technology that sits behind them. And then thirdly, we have a recorded presentation from Janheim Broders from ADI, focusing on remote monitoring. Although his colleague Anthony Hayward will be around for the live Q&A if you have any questions following their presentation. So it's enough from me. We'll firstly hand over to Philip from Microchip.
All right, thank you, Liz, and thanks for the invitation to share some of our thoughts on this. So let me just pull this up, put this in presenter mode. So are you seeing my screen now?
Yeah.
Yeah, so we're good to go. Right, okay, so my name's Philip Hart from Microchip, and I'm going to give a short presentation on our approach to helping companies develop smart, connected and secure medical devices. I'm not going to get into a lot of product detail. We can go into as much product detail as anybody wants, but we don't have the time and space to do it here. So if anybody wants to contact me later, then I can put you in touch, or contact Arrow, then we can go into that. But what I'm going to do is take a higher level approach of how we're approaching the current medical market. I'll start with a few slides on Microchip ourselves. For those of you that don't know us or don't know a lot about us, I'll just do a couple of summary slides so it puts in context what I talk about later. So please bear with me on the corporate stuff, if you like, before we get into what most people think is the more interesting stuff. So on this slide here, the title slide, there's a few clues here. We see ourselves as a leading provider of smart, connected, and most importantly, secure embedded control solutions. And there's our Microchip logo there that some people may be familiar with. And down in the bottom corner of the screen, you'll see our kind of unofficial logo, which is Smart, Connected, Secure, which has gained popularity recently. So I'm going to spend a couple of slides talking about security because we think that's very important. And OK, but let's have a look at the corporate stuff first. We'll quickly get through this before we go on to the more interesting stuff. End of slideshow. Excuse me. Sorry. Oh, I was at the end slide there, not the beginning. Sorry. Right, I've just run through it. So let's start again. And everything I've just said applies to this slide as well, so we'll move on. So who are we? Well, we're best known for our microcontrollers historically, but we do a whole lot more than that now. And I'm not going to read through everything that we do there, you can see that. But we basically provide a total system, pretty much everything you need to create smart, connected, secure devices. And we'll have a look at where these products came from in a little while. But just to give you a snapshot there, our run rate currently is around $6 billion a year with 19,000 employees, so we're a sizable company. And we're headquartered in a place called Chandler, which is near Phoenix in Arizona. And for those with very long memories, we actually used to be called Arizona Microchip, but we dropped the Arizona bit a few years ago now. So that's us in a nutshell. Why would you want to partner with Microchip as a technology partner? Well, I've already mentioned we have this very broad portfolio of products, pretty much everything you need to create a smart, connected and secure device, backed by development tools, both in-house and stuff we've got through acquisition. We're very well known for having good delivery performance. In the history of the company, we've never had a part on allocation, which is quite unusual for the semiconductor industry. So lead times can go out, but we're always there with the product when people need it. I'm going to talk a little bit about quality, because when we are designing medical devices, particularly the higher classes, class 2 and 3, quality is very important. So we'll have a look at that. I've got one slide on that. We are always competitively priced. Now, it's probably true that you can usually find a cheaper component than a Microchip component, but when we look at the total cost of ownership throughout the life cycle of a project and what it costs from inception and feasibility through to end of lifing, then we're always competitive there. We support all phases of the project, again, from prototyping and feasibility through to end of life, and however far into the future that may be. And some medical projects last 15, 20 years, and we will support all of those phases. And this is kind of important, the consistent profitability. Certainly it's important to us, but it's also important to our customers as well. And I'll show you on the next slide why this is. But we are one of the strongest, financially strongest companies in the industry through this consistent profitability. And that's important, and I'll show you why. We look at the growth of the company over the past 27 or so years. You'll see that every so often, and let's see if I can get this right and get my little pointer, yes. Every so often there's a downturn in the industry. Our industry goes through cycles, and there was one here after the millennium bug boom here, and then it dipped. And then there was the financial crash in 2008, and the industry dipped for a couple of years, and then there was a bit of a false dawn and another dip. And right now we're in another dip here, where our revenues are forecast to go down somewhere in the region of around 10%, in line with what happened here, here, and here. And what you can also see is that after these dips, Microchip grew strongly after every one of them. And right now we are planning to grow strongly after this one. So whereas many of our competitors are looking to reduce capacity, looking to reduce their numbers, we're actually planning the next growth phase. And that's important in an industry like medical, because if you're spending 2 years developing a product and then another 2 years getting it through approvals, what you want to know is that 4 or 5 years from now, that part is still going to be available. And if you've gone through one of these downturns and come out of it in a very poor financial state, chances are you'll be acquired and the product lines that you've got are then at risk. So what you don't want as a designer of medical products is to find out that you spend 4 or 5 years developing and getting something approved and then have somebody end of life apart. It's an absolute nightmare, and that never happens with Microchip. It's part of our end of life policy. As long as you continue to buy stuff from us, we will continue to make it and sell it to you. Okay, and that comes from the foundation of that is our financial strength. So let's move on to medical. That's the corporate stuff out of the way. A little bit more focused on medical now. Why would you partner with us as a technology partner? So we've been doing this a long time, 20 plus years in the medical industry, and we've got over 2,000 medical customers worldwide. And this includes most, if not all, of the big boys, the Abbotts, the Johnson & Johnsons, the Smith & Nephews, etc. We get around 300 million of our revenues from medical clients, so medical is a sizable business for us. Because of that, we're very focused on it internally. We have a focused group in medical, marketing, engineering, product development, etc. And this is quite important as well. We will, unlike some of our competitors, we will engage in support without restrictions, and that comes right from the very top in Microchip. So if you want to make a class 3 medical device, a life critical device, some kind of implant, pacemaker maybe, we will support you through that. and we'll help you develop that and help you get through the approvals to make that product. And as I've already mentioned, through our non-EOL policy, we will support these projects. You know, sometimes 15, 20 years into the future, we will still provide the parts for these devices. And what are we going to? Well, pretty much everything that's out there in terms of medical. We've got parts in those pieces of kit, whether it's disposable things like glucose test strips that need authenticating, or pregnancy testers, throwaway devices, right through to the more industrial end, if you like, the MRI scanners and the robotic surgery equipment in hospitals, and everything in between. So we have a broad portfolio of products going into a wide range of end devices, and all the experience gained in helping customers develop these products, and we can bring that to bear on your design. So I mentioned quality earlier on. I'm only going to do one slide on this, just why it's so important. Two reasons. One, a product that you design has to work, particularly if it's a class 2, class 3 device. It's got to work. And secondly, those devices have to go through approvals, be it the FDA in America, excuse me, or the various European regulations. Sorry. And now quality policy is based on an automotive standard, actually, IATF 16949, and that's very high. Automotive quality is based on 0 defects, and it's sufficient to help our clients meet their requirements, which are in the US based around IS 13485. It will be MDR in the EU, although that's been put back a year because of the COVID-19 thing. But the point about our quality is that we help customers meet their approvals requirements. Yeah. And of course, it not only has to be high quality, it has to work properly. So we put a lot of effort into functional safety. Again, this is born out of our long experience in the automotive industry. And this deals with things like the development tools that you're using, the software libraries that you might include in your products that we provide, the hardware itself. And again, the goal of functional safety, like quality, is to meet your requirements when you're getting products through approvals. It's to smooth the path through approvals. And we have a whole section of our website dedicated to functional safety design center. You can go there for more details, and you can talk to our engineers. We have a function group, a worldwide function group based around functional safety. So we have a lot of expertise in this area to make sure that the product's not only high quality, but that it works according to its spec. So talking about healthcare, what do we see as the current trends in healthcare? Well, one of the biggest is this idea of moving patients out of hospital and into their own homes. And I think this whole home monitoring, assisted living, telemedicine, telehealth type market was a fast growing trend anyway. But with the current crisis and the focus on us all staying healthy, I think this is only going to accelerate. And a couple of reasons for this. First of all, it's been shown that patients with long-term chronic medical conditions do better in their own home environment. They're happier and they recover quicker, providing that the care is not reduced. So there's a good reason to get people out of the hospital environment. The risk of infection is lower in their own homes, and all these other benefits. And that helps, that has a double benefit. Not only is it better patient outcomes, but it helps contain the cost of caring for that person. Staying a night in a hospital bed is very expensive. So that's one trend. We're also seeing a big trend from consumer fitness. So this is your Fitbits and your smartwatches, monitoring your workouts, etc. There's a big switch over of these guys into a more medically oriented field of play. And the reason's simple. It's the margins for them are better. It's a more stable environment. If they can get approvals on things, it cuts out low cost competition. So there's a big transition here into that. And then tied in with both of these, but particularly the first one of this assisted living home care trend is drug delivery. Not only in hospitals, but increasingly self-medication in patients' homes. And one of the big things here is this idea of compliance tracking. So very often a patient's sent home with their medicine and they basically don't take it. Either they forget, or they take it at the wrong times, or they simply think that it's not doing them any good and they stop taking it. So with smart, connected and secure drug delivery devices in the home, drug administration and taking of medicines can be tracked. So if somebody's not taking their medication for any reason, they can be contacted and a discussion can be had, which is not really possible in the traditional environment. So this whole drug delivery area is becoming smart, connected, and of course secure. So these are some of the megatrends. And then the megatrend that is above them all, yeah, one ring to bind them if you like, is this idea of the Internet of Medical Things, which is the medical subset of IoT. And we're probably all familiar with a four-stage IoT diagram here. You've got the edge nodes, the hub, the cloud, and then the end users and the data analytics at the end. And this is just that same diagram, but tweaked for medical. And this is a huge trend. It really is. This is probably the fastest growing part of IoT. IoT is growing fast. But if we look at the opportunity here and the numbers on Internet of Medical Things, it's estimated that by September last year, there were already over 430 million connected medical devices out there. And the market itself is growing at 31% year on year. And most markets at the minute are in a recession. We're seeing Internet of Medical Things, the growth rate's actually accelerating because of the current crisis, as more people want to medicate and monitor their own health at home. And just to put the numbers on that there, in 2017, this IOMT market was worth around $41 billion worldwide, estimated to grow to 158 billion in a couple of years' time. So it's a huge amount of growth going on here. SAM, for those of you that are not familiar with that term, that's just an estimate of the semiconductor market, that size out there, and that's estimated to be around 8 billion in a couple of years' time. The interesting thing about that is that all this activity globally, more than 40% of this is happening right here in EMEA, in Europe, Middle East and Africa. And innovation is going on like crazy. In 2018, there were over 12,000 patents filed in EMEA for MedTech devices. Now that's specifically medical technology devices. That doesn't include pharmaceuticals, which chipped in around another 7,000. And it doesn't include biosciences and the whole life bioscience thing, which was about another 5,000. So overall, medical in Europe was writing about 24,000 patents in EMEA, and it's way, way higher than any other industry out there, automotive, transportation, communications, or anything. All the excitement and activity around innovation is in medical, and more than half of that is actually in medical devices themselves. And that's not surprising when you realise there are over 27,000 medical technology or medtech companies in the region writing those patents. And unlike some traditional medical markets where products have a very long life cycle, kind of hospital kit and that kind of thing, in IOMT it tends to look more like a consumer type market where companies are upgrading and replacing products every 18 to 24 months. So again, this is driving the innovation, and that innovation is actually accelerating. The numbers for 2019, there were over 13,000 patents filed in EMEA, so 1,000 more than there were in 2018. So the innovation is accelerating. It's a fantastic place to be. It's a good time to be in this industry, and there's a huge opportunity. But of course, with that opportunity, there's a headache, there's a threat, because simply more connected medical devices are more targets for the cyber attackers. And we've seen some very high profile hacks over the last few years, both in IT level, like WannaCry, and in some medical devices, such as St Jude's Medical had a pacemaker, a wireless pacemaker that got hacked. Johnson & Johnson had an insulin pump, Bluetooth, that got hacked. And the results were quite catastrophic for those companies. So it's at the forefront of everybody's minds. And then smartphones being increasingly used as a hub. If we think back to that diagram about the IOMT, the hub part of that, increasingly mobile devices, smartphones and tablets are being used. And that adds another attack vector that needs to be dealt with. And then to compound the problem, there are a number of myths out there about security. And let's see if anybody recognises any of the first one we come across when we're talking to developers about security. Oh, it's someone else's problem. Yeah, it's not mine. I'm just writing a bit of code to take a signal from a sensor and put it into a register. So it doesn't matter. Security is somewhere else. It exists in the cloud, right? It's nothing to do with the edge node. There isn't the resource. There aren't the resources in the edge node to put security in there. It's a cloud thing, right? And anyway, it's complex and expensive to implement, and it'll take time and money and resources. And yeah, security can be added as an afterthought. Yeah, the old lock and stable door when the horse is bolted. Well, actually, no, it can't, because the two examples I mentioned earlier, St Jude's ended up being acquired by Abbott Labs, and Johnson & Johnson had to pull out of diabetic care because of their hacks. These are catastrophic. There was no way back for those companies after the event, if you like. And here's a popular one as well, and some might take issue with this, and I'm not going to argue this one right now. If you want to argue it, we can take it offline. But there is a growing misconception and a myth that wireless connectivity solutions, such as Bluetooth, provide their own adequate security. They don't. They are the number one cause of hacking connected medical devices. And as I said, I'm not going to argue that one. If anybody wants to discuss that, then I'll introduce you to our own in-house ethical hacker, and he will go through it in some detail for you. Because of this, because of the high-profile hacks that have happened, regulatory scrutiny is tightening. Yeah, the noose is tightening around the necks of the companies that don't take security seriously. And very soon they'll kick the stool away. So you've got to address this. It's a threat. It has to be addressed. And if anybody's interested, actually, there's a very good article in it's online, and I'll send a link to it. It's in a publication called MedTech Intelligence there. So if anybody wants to read this in more detail, then get in touch, and I'll let you have the link to that article. It's public domain knowledge. Okay, so how do we deal with it then? So there's only one way to deal with this threat, yeah, and that's security by design. Yeah, that's the only way we're going to realize the benefits of all these wonderful connected medical devices that are helping us and helping our families and loved ones. And we've got to apply best practices, and it's got to be end-to-end, sensor to cloud, multi-layer security by design. It is the only way to deal with this threat. Yeah, and there are various bodies. One I've quoted here, the Medical Imaging and Technology Alliance in the USA, and they recognize that, quote, cybersecurity is a shared responsibility, and it requires suppliers and manufacturers to use best practices. Yeah, so that's what the regulatory bodies are saying. The UK government published a Secure by Design report, which you can download from their website. I'm pleased to say we had quite a lot of input in that, in the areas of device security and firmware. So Microchip is helping set standards here, and that's not surprising because we have more than 20 years of delivering security solutions to payment card industry, PCI standards. And if there's one thing that has to be more secure than your medical data, it's your money, right? So PCI, payment card industry, that's point of sale terminals, etc. We've been doing that for more than 20 years. So we're well placed to collaborate with people to ensure that their devices are secure. So if you're thinking of getting into IoMT, the Internet of Medical Things, and developing devices and selling into that, then there are a few things you've got to do. And this is how we help our clients. You've got to develop an understanding of the end user. You've got to get right to the person who's going to be using whatever it is you're making. So the old model of designing a piece of kit, selling it to the NHS and moving on, that's gone now. There are new business models here. There's total care provision, and you look at all the successful companies in IoMT, and they're all buying into this. The days of proprietary products are over. It's got to be interoperable. Open standards rule. I've talked about security. I'm not there again. Regulation I've talked about. You've got to keep abreast of regulation and comply with it. And a lot of companies we deal with don't have the digital skills. They're very good at making medical devices. So for example, they might be making a wound dressing. Now they want to make a smart, connected and secure wound dressing so that they can remotely monitor how well a wound is healing. And they don't have the digital skills. So we can add some expertise there. There's a lot of collaboration going on in the industry, particularly with healthcare providers. So it's not just sell the NHS something and move on. It's let me talk to your users and find out what we need to do with them. And there are two focus goals when you're dealing with a healthcare provider. First of all, and because it's a caring profession, and it really is when you deal with these guys, their primary goal is improved patient outcomes. And once you've demonstrated that, the next goal is reducing the overall healthcare cost. It's called value-based healthcare, and that's a big focus in the whole industry right now. So how do we help companies achieve all of these? So we provide what we call a total, a complete client solution. And in the centre of that is this value-based healthcare that I've just mentioned. And it's everything we do, really. It's the quality, it's the supply chain, it's the tools, the development tools, the functional safety, and of course we do products as well. So it's not just devices, yeah. It's the whole solution to support the development of value-based healthcare systems, and that's achieved through lowering development risk. Not only the designing the stuff, but getting it through approvals. That gives faster time to revenue and lowers the overall cost because you're not having to redesign to get things approved. And it's successful outcomes, yeah, better patient outcomes at the end of the day. So if we have a look at a bit of the bottom right there, which is products. Yes, we still do products. I mentioned we went on the acquisition trail after 2008, and these are the companies that we've acquired. So we can provide pretty much everything you need to develop your solution there. Everything from connectivity, both wired and wireless, security solutions that came to us through Atmel, memory and flash IP through SST. So we've got some great products there. And then most recently we acquired Microsemi, which took us into the area of medical implants that we've never been in before, so true class 3 devices. So we can draw on all of these products and all of the people that have stayed with us and their expertise to help our clients. And that's it in a diagram there. So we traditionally best known for this thing here, a microcontroller at the heart of the system, and now we've added microprocessors and system on chips, programmable logic, but everything around it as well. So inputs, signal conditioning, security and encryption, power management, and then the outputs, connectivity and storage. So whatever you need, Microchip can help you design that with a complete solution. And we do that for medical specifically through our medical design centre, which you'll find on the website, and which really encapsulates that 20+ years of medical design expertise, and that's available to you through the design centre. And we've just added some more of that because of the increased activity in medical this year, for obvious reasons. We've added another couple of links on here, so there you can get straight in touch with Microchip through the email there, clientsuccess@microchip.com. That goes straight through to our medical client success team. And then the other box there is you can literally online schedule a meeting with one of our technology experts. And this is an app that's on the website, and you can schedule a 15-minute meeting with a technical specialist to go through anything you want really with to do with your application and how we would help with that. So very easy to get in touch with Microchip and make an appointment, have a chat, and take it from there. Okay. So we also do a lot of demo designs. Now these are what they are. They're not a production item. You can't take this and put it in a box and sell it. What it does do is it gives you a great starting point for creating something that's similar to one of these. So whether it's some kind of medical activity tracker or ECG or whatever. So these are available. You get the full design information, all the Gerbers, board layouts, schematics, firmware, software, etc., tools, and it'll give you a great starting point. So it could save you a few months of development time to get up and running for your hardware prototyping, developing some algorithms, etc., on a real platform. So they're quite useful. As I said, they're not designed to be put in a box and sold, but they can be quite useful. Now, I'll just have a look at one of these in another slide, and that's this one here, this pulse oximeter. And you might think, well, okay, that's quite interesting, but why would I care really if I'm not making a pulse oximeter? It is what it is. What we did with that was from another division, from our secure products division, we have this red board here, which is which is our AVR IoT board. And the idea here is that that board contains everything you need to create a cloud connected solution. It's got a couple of sensors on there, environmental sensors. And the claim is that from plugging that into the USB port of your PC, you can be streaming live data to Google Cloud within 30 seconds. And we do a similar one for Amazon Web Services, and I think we're doing one for Azure as well. So whichever cloud you choose. And that's quite interesting, because if you combine that with a demo such as the pulse oximeter there, and those boards are not to scale, by the way. That space on the green board is almost exactly the same size as the red board, so they fitted together very nicely. And rather than taking data from the environmental sensors on the board itself, we took the obvious thing to do. We took the data from the pulse oximeter. And then we've gone from having a small standalone demo system that's of limited interest. Suddenly, by adding the AVR IoT board, we've got a full sensor to cloud secure solution. So that's the conversation we can now have with our clients and help you develop your solutions. Yeah, so it just takes the whole conversation to another level. So if you want to talk secure sensor to cloud solutions, we can start with this. You can put it on your own finger, after sterilizing it, of course, and within about 30 seconds, you can see your own medical data securely displayed in the cloud application. So it's a great place to start if this is the kind of thing you want to do. Yeah, and of course, it's just data. It doesn't have to be a pulse oximeter. It could be an ECG. It could be a digital thermometer. It could be any kind of sensor hooked on the end there. And we've got very quickly a sensor to cloud solution that could be the foundation of a new product. Okay, so last slide. I'm 1 minute over, possibly. Why would you partner with Microchip to develop your smart, secure medical device? So we've got this long history with 2,000 plus medical clients, including the largest medical device manufacturers in the world. We've got this huge product range across all areas of technology that you need to create these devices, given this total system solution approach. As we've just seen in the last slide, we've got this IoT cloud-based solutions that very easily integrate with our medical demo boards to create a complete sensor to cloud solution. Security I've talked at some length about, and we're very good at that. Quality I talked about and why that's important, because you have to get this through approvals, and we'll support the project right from for 15-20 years if necessary. We don't end of life things and drop your company in the mire. And one thing we did do recently, and this is how flexible we can be and how we can respond to situations. We saw a huge sudden interest in, for example, ventilator designs. So we set up this team internally as part of the medical team, this COVID-19 rapid response team. And this is global, yeah, because this is a global challenge. And we've helped with design of ventilators, supporting those designs with all the things that you've just seen, and also logistics as well. People who were already making ventilators suddenly had a huge uptick in demand from healthcare providers. So we switched production, we switched logistics to support those customers to get the ventilator production, an order of magnitude bigger than it had been. And here in the UK, we saw the UK Ventilator Challenge. We were involved with all of the ventilators that were shortlisted and ultimately chosen for increased production. So we helped in a big way with that. And the next one, and this may be something that some of you might be looking at, moving on from the Ventilator Challenge, is a portable diagnostic device that can be used in the home. And we're seeing the first inquiries for that kind of device. So if anybody's got any interest in creating something like that, then get in touch with us. We're trying to track these and look for the likely winners and help people develop these things. So there's a call to arms, if you like. And I think that is my last slide, and I'll put it to the end slide there, which was the first slide you saw by mistake. And thank you for your time. So that's mine. Now, I'm not able to see chat from here yet. I don't know, Liz, have there been any questions in chat?
Yeah, I think there is a question.
Right, so how do I stop sharing here? Stop sharing, that button there. Okay. Short conversation. Ah, okay.
I think there might be a couple of questions.
Yeah, there are here. What's the most innovative IOMT product you have provided parts for that's currently on the market? I don't know, because this is a global company, so I don't know what they've done out in the Far East, and I don't know what they've done out in the US. The one I've personally been involved with was a smart wound dressing that was a device that helped wounds heal faster by providing some vacuum force to it to kind of stitch the wound together. And that was connected so that they used a very clever way of the problem with wound dressings is that if you disturb the dressing, you disturb the wound. So rather than take the dressing off and have a look at the wound, they had ways of determining how well the wound was healing and transmitting that out. So they were able to only disturb the wound dressing when absolutely necessary, and that was kind of speeding up the healing. So that was a really interesting and innovative project that I personally was involved in. But I don't know what else is going on out there. There must be other stuff that's just as interesting. Do you implement NDAs to cover conversations if needed by the companies? Yes, we do. We have a standard form, a very simple standard form of NDA. It's 1.5 sheets of A4 in not too small text. We will consider other companies' NDAs. That can delay things, but the short answer there is yes. Okay. What is the relationship between Microchip and Sensor City? Seymour. So far, not very much, but we'd like to enhance it and grow it going forward. So, Liz, maybe we need to have a conversation after this to see how we can help and see if there's anything we can provide there in terms of demo devices and support, etc.
Yeah, definitely.
Okay. So those are the three questions that I can see there. Has anybody got anything else? Just do all into silence. Either that or they're all on mute and gone for breakfast while I've been presented. It's happened. You can never tell, can you, on these? Okay. Oh, can we get your slides? I hope so, yes. I'm still waiting for final approval from our Marcom department who have to approve everything. Because we're a large American company, we have to do everything by the book. If it was down to me, yes, no problem. But I'm still waiting for sign off from Marcom. So as soon as I get that, I'll PDF them up, send them out to Arrow, and they'll be distributed. Yeah. All right. Well, if there are no more questions, I'd like to thank you for your time. I think I got through the whole presentation with only one part number in there, which was good because I didn't want to concentrate too much on parts. And yeah, thanks again to Sensor City and Arrow for inviting me. And I hope you found it interesting. Okay, thanks. Back over to you, Liz.
Super, thank you very much. Our next presentation is from Scott Cooper from Silicon Labs. So Scott's there, I'll hand over now.
I am. Good morning, everybody. Hopefully you can hear me okay.
Yes, thank you.
Yep, we can hear you fine, Scott.
Okay, let me just try and share my screen. 1 second. He says 97 screens open. Just bear with me. Can you see my screen?
Yes.
Okay. Now, is it still viewable or has it gone quite small?
It's centered. I can still see it.
Okay.
We will be just sharing the slides afterwards. So
no problem at all.
Can we relook?
No problem. I've got one of these very large widescreen monitors, which sometimes on Teams comes up with a different size. But okay. So if you're ready, good morning, everybody. Thank you very much for taking the time out to join us for my presentation. My name's Scott Cooper. I'm Regional Product Marketing Manager for our IoT products. So from a Silicon Labs point of view, what does IoT mean? It means all of our wireless products, all of our microcontrollers, and all of our sensor products. So today I'm going to take you through some of our our areas around wearables and connected health, with a particular focus on the wireless and Bluetooth connectivity side of things. So in terms of an agenda, we're going to look a little bit high level at some of the typical medical applications and use cases we see. Then we're going to talk a little bit about some of the challenges associated with bringing wireless technologies into those applications. Then a little bit of focus on our wireless Gecko platform, and in particular a recently launched new Bluetooth device, the EFR32 BG22 family. I'll touch upon the wireless security and the software around that, and then a very brief slide on sort of development tools and the modules, and then hopefully have enough time for some questions at the end. So in terms of applications, I'm going to particularly focus on diagnostics and health and patient monitoring and drug delivery systems on here. So one of the biggest markets we see, particularly when we start adding wireless connectivity, is around diabetes monitoring and control. So monitoring of blood glucose levels, etc. There's a number of scenarios and ways that we can address those, and a number of ways that patients or users can interact with the delivery of insulin, for etc. So I'm going to talk a little bit about some of the metering and some of the continuous glucose monitors that we see being more widely adopted. Then some of the other areas that we see in terms of health and patient monitoring, such as blood pressure monitor, heart rate monitor, blood oxygen levels, etc. And then touch on a couple of the other requirements really that we see are driving demand for wireless technology, and some of the sort of key requirements to be able to address those markets. So the more traditional blood glucose monitoring are where you effectively put your blood onto a strip and it would measure your levels. This usually comprises of a separate reader where you insert the strips. Typically there would be some sort of microcontroller or a display and some analog front end that goes into that design or into that application. What we see is an increasing number of customers and users that want to have that wireless connectivity to connect to their smartphone or their tablet, or to share that information with various medical colleagues, etc. Bluetooth seems to be the most dominant of technologies we see in this space, predominantly because of that need to connect to your smartphone or your tablets. I don't think it's any surprise to us. We see this on TV and on the news all the time about the increasing number of diabetes seen in the UK, and not a CAGR that we're happy to see here with such good growth, but it is reality where we are seeing a very significant and consistent growth in diabetes within adults, and that is why we are seeing an increase in demand for being able to diagnose and measure blood glucose levels in the market, as opposed to the traditional sort of blood glucose meters where you are putting blood onto a strip. We see an increasing number of users that are using a continuous glucose monitoring. Usually this is a patch. It's usually worn on the upper arm. Certainly my boss is a very avid user of this, has been using it for many years, and this effectively is constantly and continuously measuring your glucose monitoring, and then you are reading that information via a Bluetooth connection, typically to a monitoring display, whether that be a separate display or whether that be your smartphone or tablet, as I mentioned earlier. So some of the innovations that we're seeing and what is driving this connected diabetes device, or CDDs as we sometimes call them, is being able to much more tightly control what your blood glucose levels are, having a constant view of how they're changing so that you can better interact with that, and also make sure that you are administering the right levels of insulin at the right times, rather than having to run into significant issues without that close monitoring, where typically you may monitor yourself or measure via the traditional routes perhaps twice a day, or when you are feeling unwell. This gives you a constant view of what your levels are. And in some cases, these connected continuous glucose monitoring devices, or CGMs, can directly interface to the insulin pump. So it will actually automatically infuse insulin at the right time. But typically we see more, it's a measurement, and then injections are done manually. What's required when we start talking about connectivity to the phone is that we need to make sure they're interoperable. We want to make sure that any patch that is carried, or any glucose monitoring device, has got interoperability with a very wide range of smartphones on the market, whether they be iOS or whether they be Android based. And what we are seeing is that many of those applications are becoming very much more sophisticated in terms of the information they use, in terms of the display, and in terms of the interaction that the user has with their monitoring system. What we're also seeing, of course, with many of these patches and many of these CGMs, is that they are becoming disposable. That drives, of course, cost, but it also drives making sure that we've got the lowest power consumption. You know, you want to get the longest life you can from the battery, so that you are only disposing it after a long period of time. What we're also seeing is that the demand for these CGMs is driving the size down of these designs quite a bit. So we are seeing that leading to much smaller packages and much smaller devices being incorporated. That typically drives some of our packaging decisions around BGAs and some of the smaller packages that we see in the wireless space. And last but not least is the security. Clearly, we need to be very cautious and careful about sharing our medical information. When we've got any wireless connectivity, we want to make sure that they're as secure as possible. There are many organizations that are starting to drive those definitions of what are required, both from a hardware and a software point of view. And many organizations and countries are dictating that they need to be able to meet the latest stringent security requirements. But also it needs to make sure that when there is a loophole or an issue identified around security, that there's the ability to be able to upgrade the product to be able to defend against that security loophole. So let's have a look at wireless connectivity and some of the considerations that become very important when we start looking at adding wireless connectivity. But typically we want to be able to support some wireless standards rather than this be proprietary, because we want to interface with a wide range of tablets, smartphones and PCs. So having a standard that is widely adopted is very important. That's really what's been driving direction towards Bluetooth. You want to make sure that your design can support not only the latest stack version, but also that there is an upgrade path to the later and greater versions as things evolve within the Bluetooth SIG. You want to make sure that you've got the very best link budget. So that's the best RF performance, because you may want to cover a greater range, but typically by increasing the transmit power of your Bluetooth connection, you start to draw more power from the power source. And what we're really trying to do here is make it as efficient as possible and to get the very best longevity from that power source, whether that be a coin cell or another battery technology. So having really good link budget is really important, driving that to make sure that you've got the lowest transmit possible, but still achieving a good RF connectivity. We often see as well that there's a need and a demand for protocols to coexist. It may be that you are communicating not only by Bluetooth, but you may want to support other protocols, whether those protocols are proprietary, whether they be home automation type of protocols, alarm type systems where you may not want to notify people outside of your house that you're having issues, but also Wi-Fi, which we commonly see. So the coexistence of Bluetooth and Wi-Fi is an important aspect that needs to be taken into consideration when designing. And with many of these devices, there's a very lengthy FDA process that goes ahead for getting approvals. We want to make sure, and the customer wants to make sure, that they've got longevity of supply of any technology they decide to design into their products. I mentioned about security. This is no longer a would like for many applications, it's a must have, and we are seeing across many regions of the world that this is being dictated by authorities, that there needs to be a level of security. The FDA, for instance, has drafted some guidance around cybersecurity in medical devices back from almost 2 years ago. What we also need to make sure is that any technology allows us to upgrade our products as and when any loopholes are identified. And just to reiterate, making sure that we can maximize the battery life, making sure that we can achieve the very lowest power required to run that device means that we can run for a much longer period. It means that with when these are disposable, that it can last a much longer time before that has to be discarded. So these are three of the main considerations. It's about the RF, it's about security, and it's about having low power. So let me introduce the Wireless Gecko platform. I'm sure many of you have seen this before, and I've certainly presented in the past at Sensor City to talk about our wireless technologies. We have a platform which is called the Wireless Gecko. Our Wireless Gecko supports a whole range of different protocols depending upon the families, right through from Bluetooth to some of the smart home, smart city protocols such as Zigbee, Z-Wave and Thread, but also support for proprietary as well. So we do see quite a lot of proprietary RF, whether that be sub-gigahertz or 2.4 gigahertz around the globe. So really what's the driver behind Wireless Gecko platform is to have that as a platform. It means that we want to make sure that we've got the very best RF performance, the highest performance, but also making sure that we can run this at very, very low powers, because many of these applications will either be coin cell operated or potentially could be energy harvested powered as well. And as I mentioned before, having security, both in terms of cryptography, but making sure that we have a secure way to boot the device, and that we have a secure way to access any debug, and this ability to do a very secure over-the-air update as and when required. So I'm going to introduce now the BG22. This is the short name for it. It's actually an EFR32, which is an energy-friendly radio 32-bit. It's the BG22, so it's Blue Gecko, and the 22 is our very latest device, which was launched just around a month or 6 weeks ago, in full production now. This is a very capable device designed for high volume applications where power is of the utmost importance. So in terms of what is on a device, I'm going to show you a block diagram at the moment, but just to give you a high level view, on chip it has a PA which allows us to transmit up to 6 dBm, and in some cases we have the ability to also transmit up to 8 dBm. Full support of Bluetooth stacks and including some of the 5.2 capabilities. Hold on one second, my PC has just gone into meltdown. Hold on 2 seconds. Okay. And also, as I mentioned, really good RF sensitivity in terms of receive. This is really important because we want to make sure that we've got the very best receive sensitivity so that we don't have to increase the transmit power higher. By increasing that transmit power, we actually have a negative effect in terms of what the battery power and performance is like. In terms of the radio, we support all of the Bluetooth 5.0 extensions, such as the 2 meg, the high-speed PHY, and also the long-range coded PHYs as well. This BG22 also supports all of the latest 5.1 extensions for angle of arrival and angle of departure. So this allows you to do very accurate indoor location type systems. So many applications for this outside of the medical space, such as asset tracking, but also there's some interest we see within the medical space where you may want to track equipment within a hospital or within the home when you have a number of devices, whether they be gas bottles, which are for taking in oxygen, or whether they be medical devices. that you just need to know the position of those to a very accurate level. In terms of its power performance, these are absolutely world-class figures in terms of our power. In terms of transmit, this is a 0 dBm performance. We get down to 3.5 milliamps of power, which is exceptionally low, lowest in the market. And our receive power 2.6 milliamps. But we also have the ability to go into a very low sleep state where we can effectively close off certain parts of the device and only wake them when we need to. In terms of software, I'm going to focus around the Bluetooth low energy side of things. So for typical point-to-point connection or point-to-multi-point connections, but we also do support Bluetooth mesh and the low power nodes with this device as well. And as I mentioned, some of the direction finding. In terms of packages, these are fitted into very small 4mm by 4mm QFN 32 packages, including the thin quad flat pack that we have there as well, which is a very low profile device, which we see of great interest in the medical space when it may need to go into a CGM, for instance. All the devices, as you'll see in the block diagram, I'm not going to go into details on these at the moment because the block diagram is going to explain it, but it's got a Cortex M33 as the center microcontroller in there, which brings us the benefits of having Trust Zone and all the benefits that Trust Zone brings us in terms of being able to have secure and user accessible areas of flash. Different families and different versions of this, but with up to a 512K flash. Mix of peripherals that I'll show you in a moment, and making sure that we have the very latest of security capabilities, which I will cover in a bit more detail. But this has some hardware acceleration blocks, both for AES 128 and 256. Also acceleration for some of the hashing technologies and ECC, so elliptical curve cryptography, very high levels of security that are sort of banking level. It's also got a TRNG, so a true random number generator that meets some of the most stringent NIST requirements. And quite a unique couple of features here is a secure boot with root of trust built in and secure debug, which I will cover as we go through the slides. It would be wrong of me not to show a block diagram of some type or another, but this is at a high level. If you haven't seen our wireless Gecko platform in the past, I should explain what these different colors mean. What they mean is that these are the different power levels or energy levels that we can close certain blocks off to. So if you look at EM0, that's where everything's enabled, including the full core. That's where everything's running. And at the other extreme, we have EM4, which is our shut-off mode, which is a very, very low, very low power mode. And even in that state, we still have certain blocks enabled, like the RF sense and like some of the GPIO wake up and backup real-time clock. So there's a number of features that we've got there which can go into a very, very low power and be used to wake up the device as and when it needs to. We've also got this peripheral bus, which allows the peripherals to communicate with each other at this EM3 level. So you can again shut down the device to a very, very low sleep performance. I'm going to give you some figures in a moment about the battery life and the power consumption for real applications. But this gives you an idea of the sort of levels of intricacy we put in the device to make sure that we can reduce the power to the absolute minimum. Another important feature on here, as you can see, there is in the clock management block in the middle at the top there is a precision low frequency RC oscillator. This effectively means that you do not need to have an external crystal for most applications. You can run from the internal crystal oscillator, low frequency crystal oscillator, which can run at a low power. And that also means that you can run it across the full temperature range and across the full voltage range as well. I know that some of our competitors talk about having similar functionality, but that's not across the whole temperature and voltage range. We've got a good mix of peripherals here in terms of serial interfaces and as a 2-channel PDM, so that you can put things like microphones on there as well. A whole range of different timers and an ADC, good performance ADC built into it. If you look on the right hand side, this is effectively a two-core device. We've got the M33 in the top left-hand corner, but we also have a Cortex M0 Plus in the bottom right-hand corner, which is used for the low-level radio type of things and the sequencing. It's got a built-in PA. It's a fully compliant Bluetooth 5 radio, as I mentioned, but it can also be used for applications where you may want to run an 802.15.4 or a proprietary 2.4 gigahertz radio. And we have a radio crypto block. So we're encrypting radio, but at the top right-hand corner, you can also see we have hardware acceleration, so you can be encrypting your application as well. The two important blocks I want to point out here is your secure root of trust. This effectively means that you are checking the earlier phase to make sure that you are only updating or booting from a secure, trusted firmware. And there's a number of things, but I'm not going to go into detail in this call. We are covering that in a great deal of detail on our workshops that we're currently running, which I was literally on 2 minutes before the call I've just joined with you guys. The secure debug is a really nice feature as well. You would expect when you take a device to production that you would disable your JTAG, and that is a common practice when you are shipping a product. You know, the issue comes when you want to actually bring that device in because you may want to do some fault analysis, or you want to do some further discussion, or you've had an RMA from a customer and you want to have a look at it. Typically, when you would bring a device in, you would unlock that debug, and by doing that, you would clear your flash. Now, with our secure debug, we have a secure debug lock and unlock capability, which means you can securely unlock that using a secure key exchange, meaning that you can still retain the flash and do a full failure analysis. In terms of the performance, in terms of battery life, these are real use cases rather than we talk about milliamps and microamps here and there. These are a couple of real use applications, one for a data transfer and one of them is for a location service where you're using RSSI to determine where you are. So the one on the left, not going into too much detail, but this is using the high speed 2 meg PHY. We're transmitting 10 bytes per packet, and we are connected to a phone at a 2-second interval. So quite a usable data transfer, very typical type of implementation. The average current there drawn is around 4 microamps, and that would allow us to run for over 5 years on a low cost CR2032 coin cell and up to 10 years on a higher end coin cell. So really good performance that we see from that in terms of power consumption for real applications. How would you use this within a medical device and a medical design? A number of ways that you can run this. You can run the BG22 as a radio and with the MCU. So you would effectively have that as your only controller within there. That would connect to your analog front end. So no need for any external host controller in this case. You'd run the application within that BG22 using the onboard flash, and we have a number of serial interfaces that allow you to connect to that front end. But often we see that there is already a resident host processor, and this would effectively or could effectively run as an external network co-processor to that via some serial interface. And this is very common, which we see was there may be a resident microcontroller where this is effectively just acting as a network co-processor. Just a little bit more detail on that security that I talked about. It's an M33 core, so that does bring you that benefit of trust zone in terms of being able to isolate certain areas of flash. I talked about the hardware crypto blocks. These can really significantly improve the performance. The more you can do in hardware, that means the less you need to do in software. A very high functional performant true random number generator, which are compliant with some of the highest security standards. The root of trust as well that I mentioned. I'm not going to go into detail on this call. It's a whole new area and a bigger subject to cover, but it's got some inherent built-in capabilities to make sure that you cannot be injecting malware, and you are checking the previous stage and making sure that no one has got the ability, without making sure that it's a trusted source, to be able to update the device. That makes sure that it's authentic firmware, and it makes sure that you're only updating from a secure source. I mentioned about the secure lock and unlock, so I'll move on from there. In terms of the radio, so as I mentioned, 5.2, It's worth pointing out Bluetooth 5.2 also covers some of the audio capabilities for low energy. We are not incorporating those into this device. We're not supporting those functionality, but one of the key things that we did see of 5.2, which we are supporting, is the ability to dynamically adjust the transmit power. So you can use this to see whether whether your signal is getting through. If not, you can dynamically increase the transmit power. So you can be monitoring RSSI, for instance, received strength signal indication. And if you aren't getting that in, or you're dropping packets, you can dynamically increase the TX power. So that's quite a nice feature that we see a lot of interest in the IoT space for maximizing performance, but not at the cost of power. As I mentioned, it's got the 5.1 additional features of AOA and AOD. We are on the working group and steering committee within the Bluetooth SIG. We're very advanced in terms of having our capabilities. We've got the best performance out there. That again is a separate discussion. Please let me know if you want more details on that. I think that's probably enough information at this moment in time. Just to talk about the Bluetooth stack, it is more than just a basic Bluetooth stack. It allows us to do these secure over-the-air updates. You have a multitude of different ways that you can incorporate the device so that you can run an application and run this as a co-processor, so running the application on a different microcontroller if required. We've done a lot of work around coexistence of Wi-Fi. So we have got a very capable radio that can work in the same environment as Wi-Fi. Obviously, you've got 2.4 gigahertz and you've got Wi-Fi pumping out at a very high power. So we effectively implemented a handshaking scheme, which means we wouldn't be transmitting on Bluetooth when we are transmitting on our Wi-Fi. So we handle that and manage that in a very cohesive way. And we support Bluetooth, Apple HomeKit if you do want to build this into a broader ecosystem to communicate with other HomeKit devices. In terms of the BG22, there are 3 different classes of product. On the left-hand side is our high-volume entry-level product, very competitively positioned in terms of performance and the price point. As you can see, what we've done there is we've made sure that it does fit those high volume demands. So it is a device that's limited to 0 dBm of transmit power. The flash is 352K, so more than capable of running a Bluetooth stack and also some application code in there as well. And it's limited to the industrial range of -40 up to 85 degrees. Moving to the center, we've got a really mid-range product here, which is a sweet spot we see for a lot of Bluetooth applications. It's a 6 dBm transmit power, and we've got it in a wider range of different packages, and also increased the GPIO up to 26 because of that, because we've gone to a QFN40 package there. And on the right-hand side, we've got the Rolls-Royce of the products. This supports all of the Bluetooth 5.1 extensions, so it's got the high-speed PHYs, it's got the coded PHYs, supports low-power nodes within the mesh technology, but also can handle the IQ sampling. So if you're looking to implement this into the receiver of any location-based system, it can do that. All of the other devices can work within the tag, so it can do the transmitting, but this will also work in the receiver side of things. It's a larger flash device up to 512K, and we support some higher temperature up to 125 degree within that family as well. So they're the devices. For those that know Silicon Labs, we are relatively unique in the fact that what we do is we take our chips and we make our own modules. We're not relying on third parties to do that. We take them, we build our modules. We've got a great deal of experience and expertise about performance, making sure we can squeeze the most out in those modules, and also really incorporating as much functionality in there and making sure that these are certified. And that is a really key point. So we've got 2 modules. These are sampling at the moment. I wanted to give you the heads up. Ordinarily I wouldn't, but these are looking to go to production, some of them at the end of this next month, so in June. There are two form factors. We have system in package and we have PCB modules. System in package is a 6mm by 6mm device, transmit up to 6 dBm, just looking at the time, 6 dBm of transmit power, built-in antenna, built in all of the passives, This works up to 105 degrees, and a really key point here is it comes fully certified. So CE certified for Europe, FCC, but it also has certifications for South Korea, Brazil, Japan, and a number of other regions as well. It uses the same stacks, it's using the same underlying technology, so it gives you a path. If you start with the module which comes fully certified, it gives you a very easy path to migrate to an SoC as and when you feel that there is the right time. Of course, what this does remove is your need to have that detailed RF and antenna design, because that's already done for you. It also reduces and removes that need for you to be able to do any certification for the RF certifications, as they already come on the device. And below we've got a PCB module. Now this allows us to transmit up to 8 dBm, and again, slightly bigger, but it's slightly easier to place. Both of them have the antennas built in, both of them are fully certified, and both of them work up to 105 degrees. So I would suggest any interests in these, please reach out to Arrow. We can help move you forward, and as long as some criteria is fulfilled, we can sample you on those. All of these come with a 10-year lifetime commitment, as do our SoCs. Having our own module based upon them means that we can control that. We aren't limited by any third parties in terms of supplying the key technology into that. So these are really killer products. These build upon our existing family of Bluetooth modules that we are very successful and growing a very significant business on. So getting started in terms of a development environment, the BG22, there is a wireless starter kit. This is quite a full function kit, as you can see on the left hand side here. It builds upon our wireless SDK, and where you plug in different radio boards. So this is quite a generic platform we use for all of our wireless technology, whether that be Bluetooth, Wi-Fi, Zigbee, Thread, Z-Wave. We use a common platform. But on the right hand side, this is a really exciting product. It's a Thunderboard. It's built upon our technology. It's very low cost. It's sub $20 for this board. And what it's got on there is a range of different sensors, which I'll cover in a moment. And it's got a JTAG port. So in a bit more detail, what does that look like? It's quite a small board. It's something like 4 centimeters by 3 centimeters or something similar to that. It's got our BG22 on there. It's got some LEDs. It's got some buttons on there. It's got a magnetic sensor. It's got a microphone left and right. It's got an ambient light sensor. It's got a temperature and humidity sensor, and it's got a Sega J-Link debug port. So this is a very useful, low-cost development platform where you can very easily start to develop a product based upon it. It's also, of course, got on there a 6-axis accelerometer as well from Inventions. So just to complete in terms of where we fit, what we can bring to the table in terms of wearables and medicals, we have a whole range of SoCs and modules built upon a common stack, common development environment. So we're providing development kits, SoCs and modules, the software that will go on top of them, a whole range of different mobile applications, both for iOS and Android, and a free of charge, free to download development suite of tools, which not only incorporates and includes the compiler and the debugger, but a whole range of other tools, including demos, evaluations, examples, but also tools for doing power analysis and network analysis built into that. With that, I think I've probably eaten up my allocated time. I probably have a couple of minutes for questions. So Elizabeth, have I got any time for questions? Is there any questions that have come through?
Yeah, I think there is a question in the chat.
Okay, let me stop sharing. Have I stopped sharing my screen?
Yeah, you stopped sharing, Scott.
Okay, let me.
I'll fire the questions over to you.
Yes, please, if you wouldn't mind.
First question: what do you think is going to be the next big development in wearable technology?
I think there's an increasing number of sensor technologies that are going to be incorporated. We do have a range of sensors which I hadn't covered on here, but accurate measuring of body temperature. Obviously, that's becoming very relevant at the moment with the horrendous situation we have with COVID. But being able to very accurately measure temperature is an important aspect. At the same time, we see a number of sensors around heart rate monitoring. But I think for the sort of situation where we are at the moment, we've got a number of customers that want to incorporate accurate sensor technology with a Bluetooth capability. So that information can be shared over a short distance, but then also within the gateway, you would have a broader access, whether that be a 3G communications or a Wi-Fi connectivity, so that can be shared on a much wider basis.
Cool. Next question for Robert Layton. We're developing a monitoring products, care monitoring products, and considering using Scilab standard board sets. In retail BLE products, made a great demo sensor device with it. It is currently CE approved, or is something we will need to do ourselves? So I think it's already CE approved.
Yeah, from a module point of view, all of our modules are CE approved. When you do a chip down design, that is one of the steps that you would need to go through. You would need to submit the design for CE approval. And then, of course, with Bluetooth, there is a Bluetooth SIG approval that you require. But we do all of the RF certifications with modules. But that is something you would need to do yourself if it's a chip down design.
Just to clarify that,
sorry, go on,
Scott. Yeah, on my question, the product we're using is your retail S2 board, Thunderboard S2.
Okay.
With all the sensors on, which works absolutely brilliantly, but I'm not sure it's actually in itself CE approved, is it?
No, it's not. I don't believe. I can double check on that, Rob, but it's not approved. You would need to take that through certification. I will double check on that. There was some talk about us certifying that board and getting that, but I will double check for you.
Cool, and I think we talked about the 5.2 audio and the geckos. I don't think there's a roadmap for that as such at the moment, is there, Scott?
No, we're not planning to incorporate that, and one of the sort of reasons is it's a very significant investment and resource that's required to do that. And to be honest, our focus is around the IoT space, which incorporates the medical and wearables that we've talked about today. But that's not a big driver that we see within the IoT space today. The biggest driver for 5.2 is this dynamic TX control. We're not looking to incorporate those low energy audio capabilities today.
Sure. And the last question, I suppose I can answer this one, is the relationship between Silicon Labs and Centre City. So I suppose this is where Arrow comes into play. Myself, Zane Mannon, the market development engineer looking after Silicon Labs. I can liaise with Centre City and Elizabeth, build upon the relationships to look for further opportunities, help you support, and maybe possibly do some hands-on workshops in the future. If this is of interest to you guys, and we get a lot of bite from Centre City participants, then we can certainly cater for this as well. So Elizabeth and I will work on this in the future.
Yeah, we'd be more than happy to support future workshops as and when things open up a little bit. In fact, we have just literally 2 minutes before I joined your call, we're running a very significant series of workshops based around the BG22, where we are running 3 of those workshops, and they comprise of 3 days of basically a 1.5 hour session each day. So we can certainly replicate that in the future as and when things start to lift up.
Definitely. I think that's it from us.
Thank you for your time, everybody. I really appreciate it.
Cheers, Scott. Thank you so much.
Brilliant. So now we will move on to the final presentation from Jan from Analog Devices.
So my name is Jan Ambroeders. I'm working at Analog Devices as a business development manager for healthcare. I'm doing this since 2008, and that was also the start that we founded a healthcare team working on healthcare applications. And the reason was that we saw more needs for specific chips and solutions for customers rather than using products from our broad market portfolio, especially in healthcare applications. And one of the reasons is that that people at that time already started to look into out-hospital applications. And with this, you have the need of chips which are tiny, since they are integrated in wearables, but also they need to be low power. And as a third point, also when volume's going up, of course, there's more pressure on the price. And that's why we started with this healthcare team, and I'm doing this now for 12 years. And I'm glad to give you the opportunity on a new family that we recently launched called the ADPD 4000. So when we look to the market today, we see that only 50% of the worldwide population has access to healthcare. So the objective really is, okay, how can we improve the system and be able to support also those people which do not have access to healthcare today. And in parallel, we see also that the cost for health is increasing rapidly. It's more than the GDP is more than 10% worldwide. But if we look, for instance, to the North America, it's over 15%. So there's a huge burden on our healthcare cost system to be able to sustain the solution and the situation without increasing drastically the cost of health. What we also look into the future is that the population of people which are contributing to the system in terms of working people and that can pay the bills, that's going to decrease, and it's expecting to decrease 16% compared to now over the next 20 years. But also the amount of elderly people will increase by 77%. So this is actually a reason that there is a focus on how can we support our healthcare system in a better way, that the support is better, but also we can do it at a more affordable cost structure. And the biggest problem we see today is actually chronic diseases, diabetes, cardiovascular diseases, cancer, respiratory diseases. In total, we see that, for instance, in North America, 6 out of the 10 adults have one chronic disease. And if we look more in detail, then we see that even 4 out of these 10 people have more than one chronic disease. And the reason for this is primarily our great way of lifestyle. So everything goes fast in the world. We have poor nutrition, less time for exercising, but also people smoking or drinking. And these are the challenges that we have to deal with. And if you look to the healthcare spend, that was by 2012 worldwide $6.5 trillion, but this is expected to grow to 18.5 by 2040. So the only reason to sustain our healthcare system is that we do things in a different way and we do it in a smarter way. The trends what we see happening with this is that there is more and more focus today on prevention. So try to look more into the performance or certain patients or persons and look at a preventive way. And at the moment we see already in a very early stage an anomaly that we can react. And if we can react, we can maybe we can really stop the disease, or we can at least slow it down, that at a later stage there won't be damage to the body. And if you start with the treatment of a disease at a later point of time, it might already that the body is failing certain functions. What we see also is that remote patient monitoring is very hot topic at the moment. I remember when my grandma went to hospital for an heart surgery. She stayed in the hospital for 2 weeks. And today you go to the hospital and you get a surgery, and within 5 days you will be sent home, and you need to recover home for 2 reasons. People tend to recover better when they are in their own environment, but secondly also you free up, of course, beds for other patients. And also how do we improve chronic diseases? That's something where we also see that wearables could help us. And the second step also, cost containment. It's an important thing. So what we see is that people want to have faster results. meaning that if you don't feel well and you go to a doctor, that after a blood sample that's being taken, you don't have to wait for 2 weeks. But with point of care systems, we see that doctors can do those tests themselves. Also, with respect to diagnosis, have systems in place which give us much better visibility of what is happening with a certain patient or person, and to have a certain outcome that is first time right. But also systems like AI are a great benefit of helping us to reduce the cost of healthcare. Finally, also improvement of workflow utilization that reduces cost, since you minimize the chance of making risk and errors. And the last area where we see medical industry changing is on the aging population. And people today, they have to stay longer living independent. So remote monitoring and supporting those people from remote, that is a big topic today, where we see a lot of activity ongoing. If we look at the healthcare system as such, in the past, when you didn't feel well, you went to a doctor, and he started to do a diagnosis. Today, we see that approach is changing. So the system, what used to be more a doctor-centric system, is more moving into a patient-centric system. That means patients or people, they have influence on their own destiny of how they want to get their healthcare and how they want to monitor themselves. And analog devices has, I think, a nice play in this field. Since when you look to the different use cases, analog devices is in a lot of situations is the provider for technologies. So we have technology to support people with cardiac diseases or cardiac measurements, like ECG, optical. We have impedance sensing technologies, optical, as I mentioned already, but we have also a huge portfolio of impedance and biomedical sensor solutions. And this is technology that we deliver to companies that are going to integrate this in the system. And for this, you have, of course, the different use cases. So if we talk about ECG monitoring, that could be used, for instance, for cardiac monitoring or blood pressure monitoring. If we talk about impedance, that is something that could be used for respiratory diseases. And with the technology from us, we see that other companies have algorithms, for instance, that actually build a complete solution, based on the final use case. And finally, this together will be integrated in systems. And that's where the sensors and the software will be embedded in glasses, in sport watches, in helmets, in jackets, whatever. And with this system in place, we can make vital sign monitoring part of our day-to-day life, since we can integrate it in devices like watches, which we are used to wear anyway. And with this, we have a continuous ability to monitor vital parameters 24/7. And what do we do with this? Either there are people which are use those devices and store it in the cloud, and they look at this as, okay, do they improve during exercise over time? Other people, they might, have someone who's really reviewing and analyzing their records. And finally, also those people can give feedback on maybe, change your lifestyle or change the medication that you have to close the loop. Talking about the remote monitoring, there are 4 main categories of the measurements that we are performing. It could be a biopotential measurement, bioimpedance, optical, and motion. In most of the situations when we talk to customers working on wearable devices, one of the 4 or multiple of those will be part of the discussion with respect to the technology they're looking for. With respect to biopotential measurement, that could be used in a wearable device, like a patch, to measure 24/7 the waveform of your ECG. Other people, they use it just, biopotential for measuring heart rate or heart rate variability. When it comes to bioimpedance, there is a wide area of where impedance is being used. So you could do it. You could use it like skin conductance measurement. What could be a measure for the level of stress that people are facing. Other people use bioimpedance in bioimpedance analysis. And with this, you have interest in more visibility about, the composition of your body, meaning, okay, how much body fat do we have, for instance, versus muscle and bone, or how much water do I have in my body? And with this, we are also able to measure, for instance, hydration and dehydration. Another technology where impedance is being used or use case that is on respiration rate measurements. So while breathing, we see a slight change of the impedance of the chest, what could be a measure of our respiration rate. With respect to optical, I think SpO2 or oxygen saturation, that is the most classical way where optical is being used. This is done for decades now. But we see more and more that people start to use also optical technology for measuring heart rate or heart rate variability. And the main reason for this is that you can place a sensor almost at any place on the body, where in relation to ECG, you need to measure somewhere across the heart. So you have 2 electrodes, and this is not making it always very obvious to integrate in a wearable device. But we see also that optical can be used for blood pressure or dehydration. So depending on the algorithms and the sensors, this technology could be used in different for different use cases. And then finally, we have motion, and motion actually is being used in all of those measurements. And the reason is that without having a good sense of what someone is doing, you don't know if you are in the right ballpark of the expected outcome, of a vital sign. So you measure by ECG, for instance, a heart rate of 150 beats per minute. What does it tell you? Not so much, unless you know what a person is doing. And if you know that, okay, you can say, okay, it's in the expected range. Nothing is happening. Nothing is wrong here. Or it could be, a heart rate, but it's rather high compared, to sitting in the chair, and just watching TV. Excuse me. But also motion can be used for fall detection, and that's why we see motion sensors often being used in devices for independent living and elderly care. And I think the last aspect where motion sensors and motion is being used is also to measure motion, to be able to compensate or to reject, artifacts coming from motion, especially in an optical application. Where you have an optical sensor, you inject light into a body, and you measure and receive signal as a result of, for instance, heart rate. And your sensor is moving, you will see a different reaction on the received signal. And without knowing if there is motion on the sensor or not, you don't know what you're measuring. So motion always, in 99 of the 100 cases, goes together with optical measurement. When we look to the wearable devices, the most common ones is what I have here on my slide. Since I'm now, as I said, 12 years in this business, and 10 years ago, people started to develop pedometers, and the pedometer, was just measuring the amount of steps. People want to add functionality, and they moved into an optical heart rate system where they integrated in this. And today we see that all those devices for sports and wellness are still there, but people want to move more to a device that has more measurements integrated. And the 4 main ones we see today where people are working on are on the smartwatch, on the bracelet, on the patch, and on the earphones or hearing aid devices. For smartwatches, we see that those are used, usually daily, for prevention, or in a semi-professional way where people want to measure their vital parameters while doing exercises. What we see with those devices is that mainly heart rate and heart rate variability is of interest for those people. But you have also smartwatches, for instance, where the main function is to measure EDA or GSR. And so electrodermal activity or galvanic skin response. And that could give you a measure on the amount of stress. Some people are just focusing on this topic. Other people want to make a device that has the capability of monitoring multiple parameters and then they combine optical with impedance. But you see also that respiration rate, temperature, and motion is part usually of those type of devices. When we talk about the bracelet, that is something that we see more happening or being used around the clock, so 24/7. And this could be used in hospitals, but also in applications like hospital to the home. Besides the classical heart rate and heart rate variability, we see here, for instance, that those devices are interesting for AFib. And when people have to deal with atrial fibrillation or hypertension, for instance, it could be that they end up finally, with a stroke. And those type of devices could help the people, to monitor a certain disease, even, without knowing this. And that makes those devices, more semi-professional or professional. And then the classical technologies that we have also with this measurements are respiration, temperature, and motion. When we talk about patches, this is often used in hospital environments, or for people which might have a disease like a cardiac disease that cardiologists want to monitor for an X amount of time. And with this patch, we see the main application is that this is being used for ECG monitoring. So measuring somewhere across the heart and be able to capture a complete ECG waveform. But also those patches could be used for AFib detection, for respiration measurement, for SpO2. But that is more a monitoring function that we see now and then, that we see being used most, by professionals, doctors, physicians, etc. And then the last area is on earbuds, hearing aids. That's a new market. We see that earbuds are which a lot of people are using while they're going out for a run. They have interest to measure also heart rate, since the ear canal is a very good place to capture heart rate. Since there's a lot of blood flow, you don't have issues with ambient light, so it's a great spot. But for instance, for hearing devices, we see that this is a great application, also to integrate motion sensors for fall detection to support elderly people. So with respect to the use cases and technology, ADI is playing in all of these fields. And I summarized already in the earlier slides on where we're playing with respect to biopotential measurement, optical measurement, motion sensing. And what we see here is that we have different use cases. What could be either heart rate, ECG monitoring, respiratory diseases, temperature monitoring, motion, stress detection, and blood pressure. And we can do these measurements in different ways, since we can get a heart rate from an optical system, a signal, as I mentioned, but we can get also heart rate from a biopotential signal. What we see also in respiratory diseases, that respiratory monitoring, that we can measure respiration rate as a measure, by an optical sensor, but we could do it also by impedance. And this actually counts for a lot of these different use cases. And what you see on this slide on the right-hand side is that for each of the different use cases, we have dedicated chips available. So we have an ECG front end, what is the AD8233. We have an optical module, ADPD188. But you see also that we have TOMT sensors available, that we have impedance front ends, and that we have MEMS sensors. I think what a lot of those use cases have in common is one device, and that is the ADPD 4000. And the ADPD 4000 is a new chip that we released, I think, second half last year. And the new generation now, it's sampling at the moment. And with this chip, we can cover a lot of these measurements. And that makes the chip very attractive for wearable applications. So looking in more detail to the chip, you see here the block diagram of the device, where the device initially is being developed for optical measurements. So we have current sources to drive LEDs, and we have transimpedance amplifiers to amplificate photodiode currents and to measure the amount of photocurrent. But what we can do with the chip also is that we support other applications like biopotential measurements or impedance measurements or bioimpedance analysis. So the chip has been developed in such a way that it's very generic and can fulfill different measurements in a small and tiny device. The ADPD 4000 and 4001, respectively, devices with an I2C and an SPI interface, they are released as mentioned, but we're also working on the next generation, what is the 41XX family, which has an improvement on overall SNR performance. So if we look to the chip in more detail and the individual block diagrams, we see that we have two input channels. And if we have a detailed look at the input channel, we see a transimpedance amplifier, where you can program the transimpedance over the interface, so from 12.5K up to 200K. There's a bandpass filter to reject ambient light from, for instance, DC light from the sun, and there's an integrator to be able to make use of synchronous demodulation to reject ambient light interference up to 100 kilohertz. The output of the integrator goes in this, integrated function, what is also the driver for the A to D converter, and that's what we have, twice in the system. So actually, you can measure two channels simultaneously. Then there's a multiplexer. So with this, you have a lot of flexibility. What type of signals you're going to route in those signal changes? There are 4 LED drivers, being able to drive up to 200 milliamps per output. And those 4 LED drivers are making use of an 8-channel multiplexer. So in practical, you can drive 8 LEDs, but maximum, 4 at the same time. Since we have 4 drivers and 8 outputs. There's a reference integrated. There is all the clocking is integrated, so you can run it from a low power 32 kilohertz clock, but also from a 32 megahertz clock. And there is a digital backend, what includes a FIFO, so you can store more data before you wake up the processor to take all the data, the parameters from the measurements. We have decimators, so you can do oversampling, filtering, decimation. There is a timestamp function, meaning if you have 3 or 4 different measurements, you can synchronize those. That it looks like they all have been taken at the same moment. And we have some flexible GPIO control. Looking in the use cases of this chip, they are pretty right. So we can use it as a multi-parameter vital sign monitor. You can use it as just an ECG monitor, but then we have also the capability to use it, in dual lead ECG solutions. PPG for optical measurement, heart rate, SpO2. SpO2 is also what I mentioned, but also, for instance, for non-invasive blood pressure. That's where the chip could be used. So with this, you could make use of pulse transit time measurement, meaning you measure the contraction of the heart by an ECG signal. You measure the arrival time of the pulse in your wrist, and as a result, of the delay or the travel time, you can have a measure on your blood pressure. And there are also additional functionalities like gesture control, motion sensing, proximity detection, what the chip is capable of supporting. So when we look to the application like an optical system in SpO2, you see that we have multiple LEDs and a photodiode. You see here my signal chain of the device. So what we do is that we inject a LED pulse or a pulse of light into the tissue. We measure the response of the photodiode. And we have a bandpass filter to reject ambient light. And then we make use of an integrator, to synchronously demodulate external interferers. And finally, we integrate the signal and we digitize this by the 14-bit A to D converter on chip. So all the timing, it's done by the chip itself, so you don't have to worry how to control this. This is actually, there's a sequencer in the chip that runs this. On this chip, we have different operation modes available. So you can do per pulse that you send by the LED, you can do an integration, but you can also do multiple integrations before you're going to make the A to D conversion. And with this, you make a much better use of the entire dynamic range of the integrator. And with this, you will improve on SNR. There is also a digital integration mode. With this, you can also improve the SNR performance. The only drawback on this is, despite you get more SNR, that you give up a little bit on ambient light rejection. And why is this? You give longer LED pulses. That means, that an external ambient light interferer also can be caught by the integrator. And if you keep the pulses of the LED smaller, you actually reject much easier ambient light interference. And we have more operations, since you can also use the chip in a float mode operation. That means you integrate light on the photodiode, but you do this at a moment that the chip is disconnected from the photodiode. So you use the capacitance of the photodiode to integrate the light and to store the charge. The advantage of this is that this gives you an improvement on your overall SNR performance. There is also the capability of driving to make use of the LED drivers as a stimulus. So you can use this, for instance, for impedance measurement of the power and other sensor that you have. And there's a TI ADC mode, what means that the transimpedance amplifier will be connected straight into the A to D converter, and you bypass all the ambient light rejection blocks. So another application is that you are connecting two electrodes to someone's chest to measure biopotential instead of optical, as I just mentioned. And you see that we have rather a funny network in front of the chip, and I explain in the next slide. So the way we design this chip is that we're not measuring ECG as a result of a voltage, what usually is done in ECG monitoring, but we are using a charge. So what we do is that we have two electrodes connected over to series resistors, what is actually the impedance of the electrode, to a sampling capacitor. We capture the ECG signal on the sampling capacitor, and at a certain moment we switch the two switches. So we close the switches and we do a kind of charge dump, as we call it, and we distribute the charge to the integrator. And with this we are able to measure a very nice ECG waveform without having issues like dry electrodes, what are going to interfere with the performance of our ECG measurements. And that's what we show on the next slide, since we did some tests with the chip, and we put our chip, with a network, what is actually a model of our electrodes with a fluke simulator. And we have two electrode models. So one is with a 51 series, 51 kilo ohm series resistor, and we have another electrode with a 510K series resistor. So it's a much poorer electrode. And if we do the measurements, based on the signal from the simulator, you see that on the plot here we have the blue behavior of the waveform, what is the good electrode, versus the red one, what is the bad one. But you see that we can almost put those waveforms on top of each other. Meaning, if you're going to use this chip, you don't have need to use the best-in-class electrodes, like the wet gel electrodes, what are being used in hospitals. But even with stainless steel or with carbon, we are able to capture a very good ECG waveform. This is something that we have patented, and that makes the chip very unique compared to other solutions what we see on the market. And then the last use case is for respiration measurement. For instance, for either impedance impedance cardiography, but also for respiration monitoring, measuring how much water do I have in my lungs. So we have different use cases where respiration can be supported with this chip. The nice thing of the chip is that we operate in time slots. So that means that once we wake up the chip, you have the influence on what measurements to do. So what you can do in time slot A is that, for instance, you measure an ECG waveform. In time slot B, you start to measure optical heart rate with green LEDs. Time slot C and D, you take red and infrared optical to measure SpO2, and in time slot F, you measure, for instance, motion or temperature. If you don't need all those different time slots or measurements, you can put the chip into a sleep mode again, and it saves your overall power. So That time slot operation is like a sequencer that we included, so you don't have to take care, you know, of the timing, but it is something that the chip does itself. So that makes it very handy to use in an application. So we will support this chip with an evaluation board. So there's a kind of wrist-worn evaluation board with a strap that we developed that interface to our interface board. And you can use this to evaluate, for instance, ECG waveforms, PPG, motion, PPG actually, you know, so heart rate variability, but also temperature. So that tool is available and can be used to evaluate the performance and to fine-tune the chip for your particular use case. So in summary, we have two families, the 4000 and the 4100 family. The 4000, the first generation, the 4100 improved on SLR performance. The chip is rather complex, so we have different modes. You can interface to different sensors, optical, impedance, ECG, so voltage measurement. But it's actually, you know, very easy to use it, you know, with all with the evaluation board we have, and also the software to support it with. The advantage also for the chip, it's smaller in form factor. So instead of, you know, having 3 different chips for doing different measurements on your board, you have only one chip. So only one chip and one power supply that you need to decouple, etc. So it saves not just board space, but also additional components. It's optimized on power, so depending on the sample rate of the A to D converter, you can scale up the performance or you can give up performance, but you win on power dissipation. It's cost effective, and yeah, overall, I think it can help you to shorten your overall design cycles. So there are companion chips. At the moment, you need a very accurate temp sensor. We have a 7422 just released. It's a 0.1 degree absolute accurate temp sensor around the core body temperature, so it's around 37 degrees, where this chip is that accurate. We have an impedance front end for complete bioimpedance analysis, so it's a chip that can measure up to 200 kilohertz. You have a wider excitation frequency, arbitrary waveform generator. There's a DFT engine where you can also measure complex impedance. So in case the ADPD 4000 is not good enough for impedance measurement, this 5940 could be an additional companion chip. We have an ultra low power MEMS sensor. We have Cortex M3 and M4 processors as a processor which have been designed for being ultra low power. There's a tiny LDO, 0.8 by 0.8 millimeters with a very low IQ. And then finally, there's a complete ADP 5360, what is a lithium ion charger with different output rails. So there's several step down converters, step up converter, you know, for driving backlights, but could be an easy chip where all the power supplies and rails, voltage rails required for the system are integrated. So I'm a little bit over time, but it was my last slide. So I would like to thank you all for your interest.
Okay, I'll stop that video there. There's a couple of questions on the recording afterwards, so I don't think we need to see them.
Brilliant, thank you very much. Does anyone have any questions that they'd like to ask following that presentation? If you do think of anything, you could be more than welcome to email them through to me and I can try and find out the answers from any of the speakers from today. Well, in summary then, I'd like to say a big thank you to Philip, Scott and Jan Hein, our guest speakers today. I found their presentations very interesting and certainly detailed. I do apologise for the slight audio delay at the end there, but hopefully you will have found the presentations of real value. Certainly something to think about when developing products for Internet of Medical Things devices and the parts and technologies platforms that can sit behind them. We will be circulating the slides after the event today. And if you have enjoyed today's webinar, then at the same time next week, we are holding our next one, which is based around 5G and connected technologies. So please do join us for that and sign up via the same Eventbrite links, or you can find all the details on the Sensor City website. The full schedule of these Arrow Comes Home webinars are running across May and June. And if you go onto the events page on the sensorcity.co.uk website, you'll find the full links to sign up for them. Other topics are including Industry 4.0 and the electrification of transport. So hopefully there will be other areas of interest that you'd like to join us for. So thank you very much again. Please do join us next Tuesday, the 19th of May at 10 AM for the next session. And hopefully we'll see you soon. Thank you very much.